recording. There we go. So at this time, we ask that you please mute your mics for the best sound experience. Otherwise, feedback could interfere with the information we'll be sharing with you today. And without further ado, here's Miss Yvette Chuka. Let me go ahead and put your PowerPoint up for you, Miss Yvette. Miss Chuka, sorry.
Hello, everyone. Welcome to Happy Math Hour on Fridays. I'm actually going to share my screen, Patricia, if that's okay. That way the animations can come in.
Okay, no problem.
And we will be sharing this PowerPoint afterwards. If you're interested, when you sign in, you'll be able to put in your email and I will send it your way. Does everybody see my screen?
Yes, ma'am, we do.
Okay, awesome. I am not logged in into another computer or phone, so if there's any questions in the chat, please let us know. And somebody, Mr. Isasi or Mr. Carizales, just let me know, as I can't see the blackboard right now. That way I know that there's a question. So what we're gonna do today is I'm gonna go over some examples, and then what we wanna do is hopefully we'll have about 20 to 30 minutes, and then we'll be able to split up into more one-on-one groups. That way, if the 1324 students need a little bit of extra help, they'll go together, and then the 1314 will stay in this room, but I'll explain to you as we go on. Okay, so the first example is to write an equation of a line given or through a given point that's parallel or perpendicular to another line. So as you can see here, they give us an equation, 8x minus 2y equals 3, and then they give us a point. So the first step is we need to determine what the slope is of this given line. So anytime that a question asks to write the equation, you need two things. You need a slope, and then you need at least one other point. So first we're gonna find the slope. So in order to find the slope, we can write this equation as y equals mx plus b. So we're gonna subtract 8x on both sides. Once I subtract 8x on both sides, then I'm left with negative 2y equals 3 minus 8x. So our goal is to isolate y, so I can divide by negative 2 on both sides. And then we're gonna simplify. So here we would have y equals negative 3/2 plus 8 over 2 x. And the reason it's a positive is you have a negative times a negative would be positive. And so from this equation, we can get our slope. So what is our slope going to be for this equation? And you can just throw the answer in the chat, or you can say it out loud. Okay, so our slope is going to be 4. 8 divided by 2 is 4. So we're going to use our slope 4. And then we're going to need a point that's already given to us. And that point is going to be 8 and 1. And let me just mute this. Okay. So for the parallel, we're going to have, sorry, I was trying to log in, but I'd rather just turn it off because I can hear the feedback. So let me just turn it off. Give me a second. Okay. So we're going to need our slope 4 and our given point 8, 1. So here you have two choices. You can use the point slope, which is y minus y1 equals m times x minus x1. Or some of you might use y equals mx plus b, depending on which method you feel more comfortable with. For this example, I'm going to use the point slope form. So we're going to substitute the values into that equation. So here I would have y minus 1, since our y is 1, for the given point 8, 1. And then our slope is 4. So we replace m with 4. And then our x value is 8. And then you want to solve for y. So first we're going to distribute the 4 into the parentheses. And so we get 4x minus 32 is equal to or y minus 1 is equal to 4x minus 32. And then we're going to add 1 on both sides of the equation. So once we do that, then we get our equation is y equals 4x minus 32 plus 1. So my equation that is parallel to the given line is going to be y equals 4x minus 31. Okay, so that's going to be the parallel. Now the important thing here is that since it gives us the word parallel, that tells us that we need to use the same slope that we found for the given equation. And that's why we use m equals 4. But on this next slide, you're going to see that they're asking for perpendicular lines. So for perpendicular, remember if your slope is, let's say 2, for example, then you want to take the negative reciprocal, which would be negative 1 over 2. So for perpendicular, we have to get that negative reciprocal. Okay, so this was just an example, but for the line that we're actually working with, we know that the slope was 4. And so we're going to be using, and you know what, let me just work it out here because I think I messed it up here. So the slope that we're going to use is going to be negative 1 over 4. Okay. So we plug in, or let me just check to make sure. Yeah, okay. So we plug in our, oops. Let me go with y minus y1 is equal to m x minus x1. And so here we have y minus. Remember, you can use this as your x1, y1. So y minus 1 is equal to our slope, which we said would be negative 1/4. And then our x1 is 8. Okay, so let's simplify here. So I'm going to have y minus 1 is equal to, distribute the 1/4, negative 1/4 x. And negative 1/4 times negative 8 is going to be what? A plus 2. So now that we have on the right side, we have distributed that negative 1/4, we're going to go ahead and add 1 to both sides. So we get y is equal to negative 1/4 x plus 3. Okay, so let me just pause for a second and see if there's any questions. So again, the important thing here is to make sure to identify if it says parallel, you want to use the same slope. If it says perpendicular, you want to take the negative reciprocal. Oh, I guess I had done it. I probably went back too many slides. But again, here was the negative 1/4. We substituted, or we distributed the negative 1/4. And once we simplify, then you can see that we get the y equals 1/4 x plus 3. Okay, so 2 things to remember. If you're asked to write an equation, you want to make sure that you have 2 things, the slope and at least 1 point. Okay, so here's another example. It says, consider the following: f of 1 equals 7, f of 0 equals 8. Write the linear function. So those are your keywords, linear function, that has the given function values. So as I mentioned earlier, in order to do this, you need to have at least 1 point and you need to know what the slope is. So from the given information here, we can get our points. So our first point is going to be, remember here, this value in here is our x, and then the function, our output is the y, which is 7. And so 1 point is going to be 1, 7, and another point is going to be 0, 8. So now that I know my points, we can find the slope, and we can use the slope formula, which is y2 minus y1 divided by x2 minus x1. So we can label our points. We can call this x1, y1, x2, y2. So our y2 here is 8, our y1 is 7, our x2 is 0, and our x1 is 1. 8 minus 7 is 1. 0 minus 1 is -1, so we get m equals -1. So now that we know our slope is -1, then you can use either this point here or this one here. It doesn't matter which one you choose. So I'm going to pick one, and then I'm going to talk about one of these as a special point. Okay, but we'll wait a second on that. So here, 0, 8 is actually the y-intercept, so that's a special point. And the reason is we can use our y-intercept form of a line. And remember that the m stands for slope and the b stands for y-intercept. So I can just plug those values in. My slope we found to be -1, and then b is going to be our 8. And so if I just simplify a little bit, then this is going to be my equation. Okay. If you forget about the y-intercept, that's not a problem. You can always use a y minus y1 equals m times x minus x1 and plug in the values. Okay, so that would look something like this. So let's say I pick this point here, then my y is 8, my slope is -1, x1 is 0. Distribute the -1. -1 times -0 is going to be 0. And then I'm going to add 8 on both sides. So y is -x plus 8. Okay, so either option is going to be okay. Any questions on this one? Okay. So the next question, find the function value if possible. So they give us our equation, and then we have, they want us to evaluate f of 1. And I made the 1 red so that you can keep track of where we're substituting that 1. So the first thing we want to do is anywhere you see an x, we're going to replace the x with a 1, as indicated by those 2 arrows. So here we would end up with f of 1 equals 3 times 1 minus 8. And then we're going to simplify. So 3 times 1 here gives me 3, and then minus 8. So f of 1 is equal to -5. What if we had -2? We would do the same thing. We want to plug in -2 into the function. So we're going to take our -2 and replace the x with a -2. So we would have 3 times -2 is -6 minus 8 equals -14. Well, this next example, we have x plus 4. So it doesn't matter. You want to take everything that is inside of this function, or what they want us to evaluate, and we're going to go ahead and plug it in for every x that we see. So anywhere we see an x, we plug in x plus 4. So here's an x, I plugged in x plus 4. We're going to distribute the 3 into the parentheses. So 3 times x and 3 times 4 gives us 3x plus 12 minus 8. Combine your like terms. So 12 minus 8 gives me 4. And so this would be our answer here. Okay, so let's try this one. G of 2, that means we're going to plug in 2. Instead of x, we don't have an x here, but we have our variable, which is t. So you're going to plug in the 2 into every single t that you see in the equation or in the function. And so if you notice here, I have a t squared and t, so I replaced them all by a 2. So then we want to use order of operations to simplify. So we have 2 squared is going to be 4, and 6 times 2 will be negative 12 plus 4. 5 times 4 is 20, and minus 12 plus 4. And so we keep gathering our terms, simplifying, then we end up with g of 2 is equal to 12. Any questions? Okay. So the next one is find the function value if possible, and now they give me t minus 2. So if we plug that in for all the t's, then we would end up with 5 times t minus 2 squared minus 6 times t minus 2 plus 4. We're going to use order of operations. So I'm going to rewrite t minus 2 squared as t minus 2 times t minus 2. And then I'm going to multiply it out, or as some of you might know it, I'm going to use FOIL. And I'm also multiplying negative 6 times t, gives me negative 6t. Negative 6 times negative 2 gives me a positive 12. And then you have your 4 here. Okay, so t times t is t squared. T minus 2 is negative 2t. Negative 2 times t is negative 2t. And negative 2 times negative 2 is positive 4. Then we're going to multiply combine the terms in the parentheses. So negative 2 minus negative 2 is negative 4t. And then we're going to distribute the 5. So we multiply 5 into every term in the parentheses. So we get 5t squared minus 20t plus 20 minus 6t plus 12 plus 4. So we're going to combine our like terms. So we have a negative 20t and a negative 6t will give us negative 26t. Then we have the 20, the 12, and the 4, and that will give us 36. Okay, so this would be our final answer here. Any questions on that? Okay, so our next problem looks something like this. So remember, in the previous problems, let me just go back. They give us this g of 2, then this was t minus 2, and now they want to know what is g of t minus g of 2. So we're going to substitute. So for these, you want to work with each piece individually. So first I'll do g of t, and then second we'll do g of 2. So if I plug in g of t or t into the parentheses, then I would get 5t squared minus 6t plus 4. And we're going to simplify this. So t squared is just t squared minus 6t plus 4. So this is kind of repetitive here. I'm just multiplying 6 times t gave me 6t and so on. So now we do g of 2. So if we plug in 2 for every t that we see, then we get 5 times 2 squared minus 6 times 2 plus 4. 2 squared is 4. So 5 times 4 minus 12 plus 4. So negative 6 times 2 is negative 12. And then we get 5 times 4 is 20 minus 12 plus 4. And all of that comes out to, what is this going to be? 12. Okay, so any questions on these examples? So these all were evaluating a function. Okay, so we're not quite done, right? So we still need to figure out what it is when we subtract. So for g of t by itself, we got this. And for g of 2, we got 12. So what we're going to do is plug in this information for g of t, and then we're going to plug this one in for g of 2. So the red part is what I got for g of t, and then the blue part is what I got for g of 2. And notice that I use parentheses around my 12. Here it doesn't make a big difference because you only have one number. But what if you had something like 12 minus t? Then you want to make sure it's in parentheses so that this negative here is distributed across everything to the right. And so if we combine like terms, then we're going to end up with 5t squared minus 6t minus 8. Okay, so I heard some stuff going on in the chat. Is there any questions there for me?
Everything good, Yvette. You're good.
Okay, great. Thank you so much. If I'm going too fast, you can tell me to slow down. Here, this question is something that I feel sometimes people struggle with a little bit. And it says, determine whether the equation represents y as a function of x. And so there's really two ways to do it. There's a algebraic way, and then there's a graphic using a graph. Okay. So by now, hopefully you are familiar with most of the graphs, especially if you covered the parent functions. So if we look at the first one, y equals x plus 4, you should kind of maybe have an idea of what type of graph that is. If you're not sure, then you can graph it using point plotting or any other method. But what type of line is this? Or I already told you. I was going to say, what type of graph is this? But I said, what type of line is this? But yes, it's a line. And so if we look at the graph, this is the graph for this equation. By looking at the graph, then if you want to determine if it's a function, then we can use a famous test. Anybody want to tell me what that famous test is to determine if something is a function? Or you can put it in the chat and somebody will read it out. So I'll give you a hint. It starts with a V.
So Yvette and answered vertical line.
Correct. So if we use a vertical line test and I draw a vertical line anywhere on this graph, you can see that it's only touching in one place. So this is going to be a function. Okay, so this does represent y as a function of x. If we look at the second graph here, what type of graph is that going to be? Any ideas? Is that a line, or what type of graph is that going to be? And I'll give you a hint. Since it has a 2, then it's going to tell us what shape the graph is. Okay, so that shape is going to be, you can apply the vertical line test. I can draw a vertical line. It only touches in one place. Therefore, this is going to represent a function.
So we have some students that answered it was a parabola. So good job.
Great. What about the third one? What type of graph is that going to look like? So this one's going to be looking more like a little shooting arrow to the right, right? So it looks something like this. But if you notice, if you apply the vertical line test, it's still going to pass. So it's still going to be a function. And then what's the last one going to be? And so since these are both squared, it tells you it's going to be what? A circle. So if you draw a vertical line, then notice that the graph is touched by this vertical line in 2 different places. So that's not going to be a function. So this is how you would determine if something represents y as a function of x. And so I encourage you, if you know what the graphs look like, then you can use a vertical line test. If you're not sure, then you would have to try to work it out algebraically, which I'll give you an example on the next slide. Okay, so y equals x cubed minus 1. Same thing, this is cubic. If we apply the vertical line test, it touches in one place, so yes. The next one, I'm going to go ahead and work it out algebraically, okay, because it looks a little different than what we are used to. Normally the 2 is on the x and not the y. So whenever you want to determine if something is a function, you want to solve for y. So to solve for y here, I would take the square root on both sides. So my square root and the 2 become a 1, or as some of us know it, it cancels out, right? And the square root of x plus 4, since I'm taking the square root, I get 2. I get a plus or minus square root of x plus 4. Okay. So what is this going to tell me? And so I wrote this, but I know I have it as type text. So let me just go ahead and press the mouse here. What this is giving us is that it's going to give us two different answers. It gives us y equals square root of x plus 4 and y equals negative square root of x plus 4. So what does this mean? Well, let's pretend that we have x equals 0. And if we plug it in for the x's, then we would have y equals 0 plus 4 equals square root of 4, which is 2. But we would also have negative square root of 0 plus 4, which is equal to negative 2. And so what this is telling you is that whenever you have x equals 2, you're getting two different answers. You're getting a positive 2 and you're getting a negative 2. And when that happens, then this is not going to be a function because the x is not going to just one y. And if you're curious what the graph looks like, this is what the graph looks like. And you notice when x is 0, you go to this point or you go to this point. Now, kind of a trick that you want to, you might be asking yourself, well, how come this one that we had earlier was a function, but now you're saying that this one isn't? If the problem gives you a square root already, then they only want you to consider this positive one. But if you yourself actually have to physically take the square root, then you have to consider both the positive and the negative output. Okay, any questions on that one? Okay, so let's look at this one. Use a graph of f of x equals square root of x to write an equation. So now I give you a graph. We want to write the equation, and we're looking at this parent function. Okay. So the first thing I always tell my class is go ahead and draw the parent function. So this is your parent function. It starts at 0 and it goes to infinity. And then ask yourself, what would I have to do so that this picture looks like this picture? Okay. So in the chat, if you like, what would we have to do in order to get this picture to be where this one is at? And you can take one point, and that's the point you can move around. Okay, so let's look at maybe, what if I add a 2 in the square root? Well, since I'm adding a 2 in the square root, then that's going to make my parent function move to the left side. So at least now I'm in the same area to the left, but now I need to go down. So to go down, I'm going to subtract 8 on the outside of the square root, and that's going to cause my graph to move all the way down to 8. So now you can see that this graph is the same as this graph. And so our equation is f of x equals square root of x plus 2 minus 8. Okay, so I'm going to give you another one. Go ahead and try this one. It's kind of similar to the other one, just looks a little bit different. And if you have a piece of paper, you can try it on your piece of paper. If you want to put in your chat what you think it is, I'm going to give you about 30, 40 seconds to try it. Okay, so just give me a second. Okay, so first you start by doing the parent function, square root of x. So notice that, let me go back. This graph is kind of pointing to the right, but this other graph is pointing to the left. So if you tried the problem, then you can follow along and see if you got the right answer here. So if I reflect on the x-axis, that means I would have to have a negative on the in front of the square root. And so now it looks like the green one. And if we look at our graph over here, it doesn't look similar yet. Try something different. What if I put a negative in the inside? Then I'm going to be reflecting on the y-axis, and that's represented by this purple graph. So at least now, and this look the same, right? And so now we can, now if I subtract the negative 2 in here, now notice my graph got shifted 2 to the right. But now we need it to go down. Okay, so I subtract 5, and that's going to move my graph down. Okay, so the reflection up here was needed, and the reflection for the y was needed so that we can get to our destination.
So Yvette, Cecilia got those transformations correct on the chat.
Good job. And thank you all for trying, because remember, when we try something, then that's how we get better at trying, right? So let's try this here. Find the following. What if we had to add these two functions together? So the f of x, I'm going to leave it in red, and the g of x in blue. That way you can follow along. So the very first thing is, what does this mean? So I always tell my students to rewrite it the way it's defined. And the way it's defined is that it's f of x plus g of x. So then for f of x, I know that it's x plus 2. That's why I'm going to substitute x plus 2. And g of x I know is x minus 2, so I substitute x minus 2. And then we're going to combine like terms. So I have an x gives me 2x, and 2 and negative 2 gives me 0. Okay, so my answer there would be a 2x. Any questions on that? Okay, so for letter B, now we're subtracting. So first step, just rewrite it. F of x minus g of x. F of x is x plus 2 minus, notice my parentheses for g of x is, and then I put what g of x is. The parentheses is important because you're going to have to distribute that. Negative for x gives me negative x. Negative times negative is positive 2. Combine your like terms, so we get x minus x is 0, and then 2 plus 2 is 4. Okay, what does the third one mean? FGX. So if I rewrite it the way it's defined, that means that we're multiplying. So I have x plus 2 times x minus 2. We're going to multiply it out. X times x is x squared. X minus 2 is negative 2x plus 2x minus 4. Combine your like terms. So here, I think I made a mistake here. So x squared negative 2x plus 2x is not going to be 2x, but it's going to be what? 0. So my answer here would be x squared minus 4. Okay. And then division, we rewrite it as f of x divided by g of x. And so there's not much we can do here, so that's just going to be your answer. Okay. And then for these problems, they usually ask you for the domain. So what is the domain of the division one we just did? So if you want to determine the domain, there's some questions you want to ask yourself. Is there a fraction? If your answer is yes, there's a fraction that contains a variable in the denominator. What that means is that now you're going to have restrictions. There are some numbers that can't be in the domain. If there's a square root, the same thing. There would be some numbers that are restricted. Okay. So in order to find the domain, we take the denominator right here, x minus 2, set it equal to 0, and solve for x. So we get x is equal to 2. What this number is, this x equals 2 cannot be in the domain because if we put 2 minus 2, we would get 0 in the denominator, which we can divide by 0. So we need to exclude it from our domain. So how are we going to exclude it? So the domain is everything except for that 2. So to write it, we say it's from negative infinity to 2, and then we use the union symbol to the infinity. So if you have the number 2 here, we're using all of these values and all of these values, but we're not going to use these right here. Okay, so we don't want this one. And so it's important that we use a parentheses to represent that that number is not being used. Okay, let's do this one. F of g times 8. We can multiply it. And so we're going to multiply x plus 3 times x squared minus 2. So we're going to multiply. Some of you know it as FOIL. So x times x squared, and then x times negative 2, and then 3 times x squared and 3 times negative 2. So let me check our work. So we get x times x squared is x cubed.
Yvette, can you take a pause? We have a question by Gabriela.
Sure. Was it on the other slide? So I can go back.
Let me ask if Gabriela, can you unmute yourself and ask your question?
Oh, yes, good afternoon. My question is the domain, when it's like, for example, for x squared plus 2, and the division from the function, how you can find the domain?
If you have 4x squared plus 2?
See, yeah, for example, and how you can find the domain?
Okay, if this is like your answer right here?
Yeah, but
okay.
And the division, but you know, we find the domain from the division and the denominator. And when it's squared, when the number is squared, how you can find the domain?
Okay, so you can put the, let's pretend this is a denominator. You still set it equal to 0. Okay.
Okay.
And then if we subtract by 2, then you're at 4x squared is equal to negative 2. Oops. Divide by the 4. And I apologize, I'm like squeezing it in here. And negative 2 divided by 4 is negative a half, right? So if you take the square root, what happens there? That's going to be an imaginary solution, right? Okay. So what this means is, since this is a squared here, you're never going to end up with a negative number in here because the square is going to make it positive. And so the domain here is still going to be everything, all real numbers, because no matter what you put in here, it's going to make it positive, which it's not going to allow you to get a 0 down here because the numbers are always being added together. And you can see that by getting this square root of a negative number inside. So your answer, you would put negative infinity to positive infinity. And I'm sorry?
No, okay, yeah, I got it.
Okay,
Thank
sounds
you.
good. And we can do more of those in a little bit. So f times g of 8, we multiply these out, right? So here we get combine your like terms. So my answer is just going to be this here. So the domain for this one, it doesn't, I didn't have it here, but the domain, you would ask yourself, do you have a fraction? No. So you don't have to worry about fractions or a fraction with a variable in the denominator. You don't have that, so you don't worry about the fractions. Do you have a square root? A square root meaning like this? No, there's no square roots. And then the last question is, do you have any logs? Here we don't. In chapter 3, you'll run into logs, but right now we don't have any. If you can say no to all those 3 questions, then your domain will automatically be negative infinity to positive infinity. So no fractions, no square roots, and no logs. It's always going to be your domain. Compositions. So we have f of x equals x plus 4 and g of x equals x minus 9. So again, you see this right here. It's better to rewrite it the way it's defined. And so what does that mean? So that means that we have f of g of x. The g of x is inside the parentheses. That means you're going to work with g of x first. Okay. So what is g of x? G of x, they tell me, is this blue stuff over here. So I'm going to replace my g of x with that blue information with the function x minus 9. So now I have f of x minus 9. So now we evaluate what this function is. So that's telling me to take this and plug it in for every x that I see up here in the function f. Okay, so I'm going to take this, plug it in for x. Notice I have an x here, so I'm going to replace it with x minus 9, and then I have a plus 4. Gather your like terms. So my answer comes out to I need to say g of x is equal to this. What if we reverse them? G composed with f. So now we're working with f of x first. So f of x is x plus 4. So we're going to take all of this and plug it in for the x in the function g, since we have g of x plus 4. And combine end up with the same thing. And I have to say that this is a coincidence, right? You're not always going to end up with the same thing here. In this situation, we did, but that's not always the case. And I get this question asked a lot for letter C. Well, what is G composed of G? So the best thing to do is rewrite it the way it's defined. So you can see that G composed of G is going to be G of X. So you work with the inside first. G of X is X minus 9. And X minus 9, you're going to come find the X, plug it in for the X. So we get X minus 9 minus 9, which is X minus 18. So these are compositions. And in a little bit, if we break out, you can ask about some more of these. Or here's a couple of more. So we rewrite it, f of g of x. And g of x is x minus 1. So you're going to take what is in here, plug it in for the x. So we get x minus 1 squared. And in some like this, and they'll leave it, they'll count it correct. However, I always recommend that you multiply it out. So x minus 1 times x minus 1. Multiply these out. So we end up with x squared minus 2x plus 1. Question on that one? Okay, I'm going to give you well, we can just keep going that way. If we have time, we can answer more specific questions. So here I have G composed of f of x. How do I know which function goes inside? It's always going to be this the second function. So if you had like G of f of h, oops, then you would have G of f, and then h would be the first one in the parentheses. Okay, so the one furthest to the right always goes inside first. So f of x is x squared. I'm going to plug that in for any x that I see. So I'm going to take this, go to the function g, and I get x squared minus 1. And then here you can see that these are not the same, like in the other example. And then g composed of itself. So g is x minus 1, plug that in. So we get x minus 2. Okay. Does the function have an inverse? I'm not sure why it looks crazy like that, but let me see. I think, let me just erase one. Well, I'll leave it like that. So does this have an inverse? So the line here is actually the blue one. Okay, so let me just write these here. So how do we know if something has an inverse? We're going to use the horizontal line test to check if it's a function, to see if the function has an inverse. But one of the things you want to check first is your graph even a function? Because if your graph is not a function, then it doesn't have an inverse. So the first question you should really ask yourself is this a function? So is this blue line a function? You can use a vertical line test. And yes, it's a function. That means that it might have an inverse. So let's check. So now you can use a horizontal line. And for the horizontal line, it's the same as the vertical line test. If I draw this horizontal line here, does it touch my graph in only one place? And it does, right? And it doesn't matter where you line the graph, it's always going to touch in one place. So this will have an inverse. Will this have an inverse? This parabola?
They're answering no, Yvette.
Okay, and the reason is because you're correct. If you draw a horizontal line, you have this touching into place, so it's not going to have an inverse. Let me give you one more. What about this one? Hold on, let me see. Will that have an inverse?
So they're answering no.
Okay, what's wrong with that one? So the first check is the vertical line test, right? Function. So if it's not a function, then we don't have to worry about an inverse. Unless they specifically tell you to only look at part of the graph. Okay. Okay, so this one here, determine whether a function has an inverse. But we don't have a graph, right? So this is where your understanding of what this might look like is going to help, because what type of function is this? And what type of graph is that going to be? Is it a circle, parabola, cubic, line?
So
Is it a
Stefan is answering a line. So is Gabriel, Excel.
correct? So this is a line, right? So I drew it here. This is a line. So since it's a line, one, that means that it's a function. And number two, it passes the horizontal line test. So it is going to be an inverse, right? So we say there is an inverse. And now they want us to find it. So let's find it. So to find the inverse, you want to replace f of x with y. So here's my f of x. I'm just going to replace it with y. And remember, f of x and y is the same thing. It's just a different way of writing a function or an equation. So we're going to replace it with y. And then the big part of an inverse is that the x and y are interchanged. Okay, so we interchange x and y. So wherever you see a y, you replace it with an x. Wherever you see an x, you replace it with the y. And now you solve for y. So subtract 4 on both sides and divide by 5. So now we have this right here. And your last step is change y to f inverse. So this would be your inverse. Okay. So the main thing is change f of x to y, and then you want to switch the x and y, and then solve for y. And I think the rest of these that I have here are more for like the third students. So at this point, go back to Blackboard. That way we can see we have only about 9 minutes, but I am willing to stay to finish up for those of you that are in 1314, or if you're a 1324 student and you have specific questions, you can stay here. We have tutors that are available right now, and so we can help you as well. Before we move or anything, I would like to just give you the link to sign in for today. Remember that I am sending it to your instructors. For some instructors, you're getting extra credit, or they're counting it as your tutoring hours. And so make sure that you fill this one out. if you're not getting any extra credit or anything like that, it's okay. You can still fill that out. And that way, if you want this PowerPoint, then I will be emailing it out to everybody as well. And I guess what I can do is also I can include the video links to these. Okay, so let's do this. If you would like to stay and finish the 13, 14 slides that I have, next to your name, if you're gonna stay, just type your class, what class you're in, and just put next to it, say stay. And then that way we know that you're staying. If you're a 1324 student and you would like to get some extra help, just type 1324 and then just write stay. And then we'll give a couple of minutes for students to ask questions or maybe to leave and stuff like that. So for example, if I'm a 1314 student, I'm gonna type in stay like this. If I'm a 1324, I'm gonna say stay. And then what we'll do is we'll just move you into different rooms here so to work with you on a more one-to-one basis.
I'll go ahead and start breakout groups, Ms. Chuba.
Thank you. And so Miss Patricia's gonna start putting you based on your responses and your name into a room, and then just wait for us there, and we'll come and answer questions for you and show you the PowerPoint that I have left, which is the distance formula and some other stuff.